Hello, welcome again to our series on speed and accuracy in mathematics. In the previous video, we focused on the shortcuts that are involved when you are solving fractions in mathematics. This time we are going to focus on radical expressions. They are also amongst the speed breaks that we have anytime we are solving problems in mathematics. In the first situation, we have the root of AB, which is supposed to be root A times root B. From time to time, we are required to use this property to simplify surds, such as the square root of 75. I would need to express 75 as a product of a perfect square and some other number, if possible. There is that possibility as 75 is the same as 25 times 3. And so I get the root of 25, which is 5 root 3 as the answer. I could also have the root of 720, some large number. I would have to, at times, use the calculator and verify a perfect square that is large and closer to 720. If that time is not there, you could just start breaking it down. I know that 720 can be written as 36 times 20 at least. It will help me to go faster than using the calculator to search some number. The square root of 36 already is 6, and 20 is the same as the root of 4 times the root of 5. And so at the end I have 6 times 2 times root 5, which is 12 root 5. This answer is the accurate answer. The tendency is for students to just arrive here and use the calculator and then be writing some decimal number. When you do that, your accuracy will be 0 and you will lose marks. So always, if you don't want to simplify, you better leave the answer as the root of 7 all over 20 rather than using the calculator to have a decimal number, because it will be an approximation. It will not be exact. The exact value is this or this, and this one is more appropriate. In other situations, we have mathematical expressions like 16x minus 16 inside the root sign. That should then be the root of 16 into x minus 1, which gives the root of 16 times the root of x minus 1, and you are left with 4 root x minus 1. So at times you need to master all these skills so that once you are solving and you reach a step, you will not be thinking of what to do. In another situation, we have the case where the root of A is raised to an even power. When that happens, it is the same as a to the half raised to that power, and 2 cancels. You are just left with a to the n. So if I had a situation where I am supposed to raise root 2 to the power of 8, what I will simply do is root 2 to the 2 times 4, and the root 2 and 2 will cancel, and the root sign and 2 will cancel, and you are left with 2 to the 4th, which is 16. If it is the root negative the root of 3 to the power 10, for example, when you raise a negative number to an even power, it becomes positive. So I would just remove the square root and divide the power by 2, and that gives 3 to the 5th simply, which is 243. In another situation, we could instead have root a raised to the power 2n plus 1. That means raised to an odd power. You need to break it down into root a to the power 2n dot root a. That will be easier to simplify, and you are just left with a to the n dot root of a. Example, root of 2 raised to the power 7 becomes root of 2 raised to the power 6 first dot root 2, and that now the root 2 cancels the 6 to give 3, and I have 2 cubed, which is 8 root 2. If I have negative root 3 raised to the power 9, if I raise a negative number to an odd power, it remains negative. Then root 3 would be raised to the power 8, and then root 3. The root sign and the 8 cancel to give 4, and then I have negative 3 to the 4th, which is 81, then root 3 as the answer. In some other situations, we have to simplify an expression like this. There is a variable out already of the root sign, and the variable is also in the root sign. Normally, to solve this, in the shortcut is simply to square the a and send it inside the root sign. So I will get a squared into ar, and that simply gives me the root of a cubed r. If you don't know this shortcut, look at the stress you have to go through. You would have to use properties of indices by saying a root of ar equals a dot a to the half dot r to the half. This would give a to the 3 over 2. Multiplying two indices, you add the powers, dot r to the half. This would give a cube dot r all to the half. The power half is common, and you now get the root of a cube r. And this takes a longer time to evaluate, and there is the risk of mistakes too. An example could be in the situation where you are to simplify root of ar all over a. In some situations, this should simply be the root of ar all over a squared. That means since a is at the denominator, I will square it and send it at the denominator of the radical there. And overall now it simplifies to r all over a, as a would cancel. There are situations in further mathematics under simple harmonic motion. They tell you that the period of a compound pendulum is given as t equals 4 pi the root of 8a over 3g. And you are asked to find the length of the equivalent simple pendulum. the tendency is usually for you to compare this period of the compound pendulum with that of the simple pendulum, which is 2 pi the root of L on G, where L is the length of the simple pendulum and G is the acceleration due to gravity. When you attempt a comparison with this one, you discover that there is a problem. The coefficient of the radical there is 2 pi, and on the other side it is 4 pi. So we need to make sure that they are the same before we can read the simple pendulum. If it were t equals 2 pi the root of 8a all over 3g, when I compare with this, I simply cover the G, cover it here, and I get L here as 8a over 3. Usually in multiple choice questions, that is where you get these type of questions. And it's easy to just read the equivalent length by covering the G's, and then L just gives 8a over 3. But then the situation we have is 4 pi in front and not 2 pi. So what I would do is to take this 4 pi and break it down into 2 times 2 pi, the root of 8a over 3g. And from there, I will now say t equals, I would eliminate this 2 by sending it inside the root sign. So again, to send it inside, I will need to square before sending. So it now gives me 2 pi, the root of 2 squared into 8a all over 3g, which now gives 2 pi, the root of 2 times 2 gives 4 times 8, that gives 32a all over 3g. And so the length of the equivalent pendulum L corresponds to 32a all over 3. If you cover the G's, if you cover the G's with the simple pendulum situation, you will see that L corresponds to 32a all over 3. And so L equals 32a all over 3. The normal way of solving this would have been to square this one, and then divide the two equations. So I would have to say t squared equals 16 pi squared into 8a all over 3g. I divide by the square of the simple pendulum formula, which is also t squared equals, all over the square there will give 4 pi squared into L on G. And when I simplify, I get 1 all over 1 equals, cancelling here, I get 4 into 8a all over 3g all over L on G. Over G cancels over G, and I'm just left with L being 4 times 8a all over 3, which is 32a all over 3. That's the normal solving situation. If you were in a paper 2 situation, for example, you could do this, but multiple choice warrants that you get the answer as fast as possible. And so using this other shortcut, the answer would come out very fast.